In 6 months, Starship hasn't flown even once. 6 months. This is the longest pause in the history of the program since the first fully integrated test flight in April 2023. And while speculation is flourishing online about whether SpaceX has lost its drive, the opposite is happening in the background. A completely new spacecraft is being built. What will be recorded as Flight 12 in the logbooks is actually Flight 1 of something that only shares its name with the old Starship. A completely new platform, new engines, new launch pad, and 3 times as much payload as anything that flew up to Flight 11. My name is Serwin, and this is Mars Chronicles. Before we get to Flight 12, we need to briefly take stock of where we stand today. Because the pause between Flight 11 and 12 should not be seen as a standstill, but rather as a period of consolidation. Version 1 of Starship flew from Flight 1 to Flight 6, that is, from April 2023 to November 2024. 6 flights. Of those, the first 3 ended in spectacular breakups. Nice to watch, but not a success in the classic sense. Flight 4 brought the first successful water landing of the booster. Flight 5 delivered the moment that was covered by every news agency in the world. The first catch of the booster by the chopsticks, that is, the arms of the tower. Flight 6 showed that it wasn't just a stroke of luck. Version 2 flew from Flight 7 to 11, covering the entire year 2025. The architecture was expanded here, about 35 tons of payload to low Earth orbit, new heat shields, improved flap control. And this is also where the program suffered its biggest setback. In June 2025, Ship 36 detonated during testing at the Mises test facility. A pressure vessel exploded and tore the entire ship apart, taking much of the test infrastructure with it. The reconstruction took 10 months. And it was exactly during those 10 months that version 3 was created. V3 is a new design. If you want to explain to someone in one sentence what V3 is, then say, 3 times the payload with only 2 additional meters in height. We're talking about over 100 tons to low Earth orbit while remaining reusable. With full expendable mode, meaning if you forgo reusability, we're talking about up to 200 tons. Those are numbers that make any payload discussion in the space industry obsolete. How does SpaceX achieve this leap in a single generation? 3 levers. The first lever is Raptor 3. We've already made several videos about that. I'll of course link them below. But the short version, Raptor 3 produces 280 tons of thrust at sea level. That's 22% more than Raptor 2. With 33 engines in the booster stage, that adds up to 9,240 tons of total thrust. For comparison, the Saturn V from the Apollo era had 3,500 tons. The Soviet N1 had around 4,500 tons. We're talking about twice as much thrust as the most powerful rocket system of the Apollo era. But Raptor 3 is not just more powerful. The real miracle is the simplification. Where Raptor 2 still had hundreds of external lines, flanges, and connections, Raptor 3 is largely integrated. The regenerative cooling of the outer components is so efficient that the entire engine heat shield could be eliminated. This saves mass, eliminates potential sources of failure, and speeds up reuse. SpaceX is aiming for a long-term unit price of $250,000 per engine. With the thrust that this engine produces, that's a figure that fundamentally calls into question industrial engine production worldwide. The second lever is the tank architecture. The common bulkhead between the oxygen and methane tanks was moved further down in the ship. Sounds like a minor detail change, but it's actually radical. More methane volume means more fuel, which means more range, which means more payload. V3 ships carry significantly more than the roughly 1,500 tons of fuel carried by the V2 generation. The third lever is the booster itself. The grid fins, that is, the rotating lattice fins that are crucial for the return and the catch, have been enlarged by 50%. At the same time, their number was reduced from 4 to 3. They are now mounted on the methane tank instead of the interstage. The hot staging ring has been fine-tuned. It's now permanently integrated into the booster instead of being a jettisonable component as before. That was the Airbender N1 from 1969. A truss design that separates the ship from the booster without needing to blow off a separate structure. If Starship excites you as much as it does me, then hit the hype button now if you've got one. And if not, a like, subscription, or comment helps the channel a lot. The algorithm will decide in the next few minutes if and to how many people this video will be recommended. And you have a say in it. We've been following every iteration of Starship development since the start. And we're staying on it. Thank you. Let's continue and look at the vehicles that will fly. Ship 39 and Booster 19. Both are the first vehicles from the V3 line. Ship 39 has been fully stacked since November 2025. In January 2026, the core PVs were replaced, the composite overwrapped pressure vessels. So, exactly those high-pressure tanks that triggered the disaster on Ship 36. And at this point, there's an important piece of information that is overlooked in most reports. SpaceX directly acquired the North American manufacturer of these pressure tanks in February 2026. Hexagon Masterworks, a subsidiary of the Norwegian Hexagon Purus Group, was acquired for $15 million and integrated into the SpaceX supply chain. If you lost a component in the past, you just buy the manufacturer in the future. That's vertical integration straight out of the textbook. In February and March, a series of cryogenic pressure tests followed at the Mises test infrastructure, which SpaceX completely rebuilt over the past 10 months. For the first time, so-called squeeze tests. A special steel structure pulls sideways on the ship's flaps to simulate exactly the forces that will be exerted when it is caught by the chopstick arms of the Mechazilla tower. On April 15, 2026, Ship 39 finally ignited all 6 of its Raptor 3 engines for a full 60 seconds. That was the first full static fire of a V3 ship. No visible heat shield damage, clean burn sequence. Afterwards, it was rolled back into Megabay 2 for final preparations. Booster 19 is the second V3 booster variant. Booster 18 was the first. Unfortunately, we lost that one. In December 2025, during a nitrogen pressure test, a component gave way. There was no critical damage to the infrastructure, but the booster was gone. SpaceX welded together Booster 19 in 25 days. That's half the time it took for Booster 18. This speed is the real indicator of the maturity of the production process. Booster 19 was on the 16th. On March 16th, it completed its first static fire with 10 engines, which was aborted after 1.8 seconds due to a premature sensor trigger. During the inspection, it turned out that half of the engines had mechanical damage due to the hard shutdown. SpaceX removed the 10 damaged engines, replaced them with engines from Booster 20, and filled all 33 slots. On April 16, 2026, the crucial test took place. All 33 Raptor 3 engines fired simultaneously for the full 15-second duration. That's more thrust than any rocket ever ignited on a launch pad. Pad 2 withstood it. What was built up at Pad 1 over years in 4 stages, the water deluge, blast suppression, and the flame diverters, is integrated here from the very beginning. Pad 2 is not just a second launch pad, but the blueprint for every Starship launch pad of the future, including Pad 1, which is currently being rebuilt, as well as 39A in Florida and Space Launch Complex 37 also in Florida. A total of at least 5 launch facilities for Starship will go into operation in the coming years. Let's move to the next test flight. What are the objectives of Flight 12? First, and most importantly, a clean ascent. SpaceX wants to see that the entire V3 system works under flight conditions, just as it was modeled in simulations. The thermal, acoustic, and mechanical loads during launch cannot be fully reproduced in ground tests. Secondly, successful stage separation. Hot staging, that is, igniting the ship's engines while the booster is still separating, worked in the V2 generation. But V3 has a different hot staging design. It's integrated into the booster nose, and that has to be validated first. I've made a separate video about hot staging. Of course, that's linked below. Third, splashdowns for both stages. Both Booster 19 and Ship 39 are supposed to land in the water in a controlled manner. No catch on the first mission from the new pad. That is a deliberate decision. The hardware is new, the catch fittings on the ship are new, and the control logic for the larger grid fins is also new. SpaceX doesn't take maximum risks on maiden flights. Only when the profile works reliably and repeatably does the catch come back into play. If everything goes smoothly on Flight 12, we could catch a booster on Flight 13 and see a second soft water landing of the ship. Maybe even in the Gulf of Mexico before they actually catch the ship on Flight 14. At least if everything goes according to plan, and we know how that usually goes. I can't emphasize that enough. The infrastructure is much more important and expensive than boosters and ships. They've set up a production line for that now, but for the infrastructure, there really isn't anything like that. Fourth, and this is optional, an in-space relight. Ship 39 didn't have a single engine static fire at the test site. That suggests that either no relight is planned or that SpaceX is deliberately skipping a ground test to keep Flight 12 streamlined. Both interpretations are plausible. Fifth, and this is very important for the future, demonstration of the PEZ dispenser. 8 Starlink simulators could be on board to test the ejection mechanism. Here too, it is not 100% confirmed whether these will be on board. And here we come to the real point that most observers underestimate. Flight 12 is the first flight that is directly prepared for orbital refueling. Orbital refueling, meaning the technique of transferring fuel between two ships in orbit, is the central technology of the entire Starship program. Without refueling, no human will return to the moon. The NASA HLS variant, the lunar landing version of Starship, which is supposed to bring astronauts to the lunar surface as part of the Artemis program, does not have enough fuel after launch to reach the moon. It has to be refueled by a tanker ship in low Earth orbit. For this, depot ships are refueled in advance with several tanker flights. V3 is the first version that, according to SpaceX, is designed for this purpose. A V3 ship can stay in orbit for 48 hours rendezvous with another ship, dock, and transfer fuel. That wasn't structurally possible with V2. With V3, it's part of the architecture from the very beginning. If Flight 12 is successful and Flight 13 then brings 2 ships into orbit that can meet and refuel, then the Artemis 3 plan will have a realistic foundation for the first time. If V3 has further delays, then Artemis 3 will be postponed further. It's as simple as that. Speaking of refueling, if you don't just want to watch the Mars Chronicles universe but also wear it, check out planetpioneers.de. Our shop? There you'll find our Ad Astra collection, which honestly has struck a chord. Caps, shirts, hoodies, neatly embroidered, organic cotton, sustainably produced in the EU. Nothing loud, nothing pretentious. Just the motto that ends every video, take it with you. Anyone who orders with the code MARS26 gets 15% off their entire purchase. Link below, and now back to the rocket. What happens after Flight 12? Ship 41 is already in the Star Factory at Starbase, about to roll into Mega Bay 2. Ship 42 to 45 are at different stages of tile installation. Ship 46 is the first so-called payload ship. So, the version that's actually supposed to deploy payload, and is no longer considered just a test vehicle. SpaceX is already working on Booster 20 and 21. The Gigabay at Starbase is nearing completion. In Florida, construction is progressing in parallel at Launch Complex 39A and in the Cape Canaveral region. There, the Gigabay will go into operation at the same time as the other one. And SpaceX announced something last week that most people are underestimating. The old drone ship, just read the instructions, on which countless Falcon 9 boosters have landed, is being repurposed. It will become the transport ship for Starship vehicles from Boca Chica to Florida. The previous transporter, Marmac 31, can only carry one ship or one booster. Just read the instructions has enough deck space for several. That's an indicator of the increase in cadence that SpaceX is planning. If everything works out, SpaceX would have 2 active pads at the former Boca Chica site by mid-2026 plus 2 in Florida. 4 launch pads. The FE permits for this are already prepared. And now the reality check. First, the FCC license for Flight 12 was extended in April and now runs until May 2026. That's the formal basis. Without an FCC license, there's no radio communication during the flight. Without radio communication, there's no launch. But be careful, that's not a launch permit. Second, Elon Musk said on April 3, 2026 that the flight was 4 to 6 weeks away. That would be early to mid-May. Realistically, I would guess the second half of May, because the red dress rehearsal still needs to happen. Pad 2 has never seen a fully integrated rehearsal with both stages. Every little thing can take days or weeks. Third, SpaceX has shown in the last 2 generations that it bounces back quickly from setbacks and scales up quickly after successes. Anyone who compares the 2023 program with today's can see that the iteration speed has increased. But 2026 is also the year in which the pause between flights is the longest in the program's history. That's the consequence when you create a completely new platform. But it also means that any failure of Flight 12 would set the program back by months, not weeks. If V3 flies and delivers, the return to the moon is a predictable date. If V3 doesn't deliver, we'll have to rethink the timelines. There's a phrase that the V3 program manager said in the SpaceX video from last week. He was standing in front of Booster 19 in the Mega B, workshop music playing in the background, and said,
"This has to be judged by the breaking rules of physics." We're not breaking any rules of physics. We're trying to use them as effectively as possible.
Something is only impossible if it breaks the laws of physics. We're not violating physics laws. We're just trying to use them as effectively as possible. That's the essence of SpaceX. And that's the essence of Flight 12. We're not building what the last 60 years of spaceflight tradition have told us is possible. We're building what physics allows. In the next few weeks, we'll find out if V3 lives up to what the renderings promise. I'm keeping my fingers crossed, and I'll be there live. Hopefully you will too. A huge thank you goes to Pusa. Without her support, this channel would look completely different. My name is Serwan, and this was Mars Chronicles. Thank you for tuning in. Through hardships to the stars. And that's the quintessence. That's the quintessence essence. That's the quintessence of we Lotto criminal.